that the time exceeded value here, Internet Control Message Protocol, is coming back and saying it's a time to live exceeded value, which means that when we went to forward this message, we decremented the TTL like we're supposed to, and it hit 0. Because it hit 0, we have to throw it away and send an ICMP message back saying that it failed. Now, of course, back up here, that was what happened on this first one. We did that 3 times. So in our Wireshark, we see it once, and then exceeded, and then twice, and then exceeded, and then a third time, and then it exceeded. And then the next one, notice the next hop went out to 10.1.1.1, which is also part of the network that I'm on. It's a private network that I'm on that's kind of up here in the internet as far as our cloud here. But that 10.1.1 router, notice that we're still sending our ICMP message to Google, right? But then we got a response back saying that time exceeded again. And, you know, we sent it to, let's see, standard query. There we go. Here it is, up here. So we're sending it out to Google, and then we got a response back saying time to live exceeded. But notice we got this from the 10.1.1.1 address. That's not a router we knew about. That's a router that is 2 hops away from us. So here's our first hop. There's the second hop. So we discovered that there was a router that's 2 hops away from us with this particular address. So we went ahead and did that ICMP request, still going to Google twice, but the notice the message going out at this point. Look at the time exceeded message, the TTL value. At this point, the TTL value is 2. So we went through the first router, our router here. We got to the second router, and when that got it, it decremented and it hit 0 at that point, and that was the router that responded back to us with the time to live exceeded message. We then continue the process for the third router here. We have our TTL value of 3, so we're going back here, and now we should see some message. There we go. At 97.76.12.1, we saw that, and then we actually did some DNS lookups for that same value. We're actually doing here, take a look at our DNS request. We were doing a pointer query. Notice what we're doing, it's a pointer, it's an inverse of the actual address. So the address of 97.76.12.1 in reverse, it's an inverse address lookup via DNS. So we know the IP address, but we want to know what the host name is. So it's kind of a backwards name resolution message. So that's essentially how we're getting the name of this particular router, which is owned by Roadrunner. Coincidentally. So we went through and we're hitting all the Roadrunner network here in Florida and Atlanta and Washington, D.C. and New York. And then we finally ended up, and there's a few that we couldn't resolve via reverse ARP, and we finally got to Google here. Now what's interesting is this one dropped, and I don't know why that one dropped, maybe busy network or something, but there's a very good reason why this one dropped here. At the very end of this string, I'm going to show you here on the trace here, at the very end of this, at the very end of this, when this reaches an actual host, when it gets these pings, since pings aren't supposed to be responded to for anything else other than echo reply, when the end device goes to respond, since it's a host in question, we're talking about a server here, it's acting and using normal ICMP rules. Routers have been programmed at this point to, if they see echo request and there's a time exceeded, it goes and is supposed to reply for all of them. But in the case of hosts, they're under normal rules for ICMP, and that is for any ICMP message, only send one error message for every other packet going out. So in this case, when you get to the end of the traceroute session, it's often an indication that you finally reached the final destination here. If it works for the first ping, fails for the second, and then fails for and then works for the third one. So that's indicative of the rules for ICMP, that it's supposed to send one error message for every other packet that it receives. So that's why you're seeing this here. Okay, so that's traceroute. One more thing to test before we go on to the next section here.